recording. There's too many buttons in the system. Okay, so before I actually jump into this, since I'm recording, let me have a look at just going through the project as a very brief kind of overview. Um, there's so many videos and stuff like that. So obviously you have the lecture video. I definitely recommend maybe giving that a quick look. And then you have the setup videos. So these are on Edge. And if we go here, oh no, frontend's not looking for what person. Anyway, I can deal with that later. And you can see the step guide here with the video. Now, if you click it, it should just work. And everything should be good. There should be no problems. But the thing is, two people had issues so far, and in both cases, they just didn't read a certain part of it. They said, make sure you do this. And they didn't do that. So read through it and like follow the video. If you follow it like as it says, where it says, so make sure that this folder's opened, and you make sure that folder's open, it should just work. It's pretty fancy with how it works under the scenes and stuff like that, so hopefully it's all good. We'll see. But yes, there's two guides just because there's kind of two parts of it. So the first one's set up, it kind of goes through how you can set everything up, has pretty images, not really, but images. And then once that's all done, it then goes to the front end and it actually gets you to write some front end code, or not like JavaScript, but gets you to write some code that will render something. So you end up rendering something that looks like this, as well as eventually rendering something that looks like this, right? So you kind of get some basic rendering there, and you can also see how you can render goals, as you can see here, some pretty awesome goals, and it's actually quite easy to do a lot of stuff. For example, these goals here, which have images and stuff, is just this. So you can just kind of provide certain strings, and the front end does a lot of the crazy magic for you. There's many things you can do with it. Hopefully it will be a ton of fun. Is there any questions about the project that you have so far, or anything that you want to clear up before we jump into the tube material? Okay, yeah, so there's stuff here. There's, I don't know, you can go through this later and you can check it, and you should start with milestone 1, kind of plan out what you want to do for the next couple of weeks. I definitely recommend you probably start this week, if not next week. My link still goes to the old assignment. Oh yeah, no, that will be your assignment one. Yeah, that's different. Yeah, so the easiest way to find links is you go to this homepage here, and you'll see the project here. That's just the easiest way to do it. Like, I think we'll look into for the future this kind of like ability to give people individual links. But it's like very clunky to kind of upgrade everyone's branches, like do merge requests and stuff. It's just not very nice. It takes quite a long time for a course like this. 1531 kind of does it in certain ways, but it still takes them forever to update specs. Let me turn off Slack. And hopefully that deployment went well. Let's see, why not? Okay, it's on the screen. Ready for PVT. That sounds like a good thing. Okay, so hopefully it went well and nothing broke. We will see. Okay, so yeah, so that's pretty interesting with the whole project thing. Hopefully it's fun. I'm just gonna jump in because there's no specific questions about it. Okay. Yeah, stuff looks fine. Oh, there's one thing I should mention, which is that the order marking here, I don't know if this was mentioned in any lectures. It's kind of a funky formula. Thank me that it wasn't the old formula. There's like two variations of this formula. The old one was like, I think it was like if you had like, what was it? Oh yeah, it was the coverage cubed times by your own auto mark, but times by like the auto marking score. And these were between 0 and 1, which meant that let's say you got like, I don't know, 70% coverage. Even if you got like 100% of the test, you'd only get 34% total. And I was like, no, we can't do that. That's ridiculous. Why would you ever design a scheme like that? I was like, this makes no sense to me. So that's basically. So I think my camera's at the top. That's fine. So yeah, thank goodness for that stuff. So it should be fine, this kind of formula. It should hopefully balance it pretty well, but coverage is definitely worth a lot. So it's definitely recommended that you get pretty good coverage, and the highest you can get is 85%. So I definitely recommend you look into getting kind of like really working towards getting that coverage high because it will actually earn you quite a bit of marks because it actually affects your auto mark. Um, so when you look at these marks here, for example, and you see that this is worth 40%, that means coverage is worth a significant percentage of that 40%. So when you're thinking about, oh, do we have time to finish this feature? You should also be thinking, do we have time to also test this feature, to write unit tests for this feature? Okay. And then the next thing I want to talk about is a few things, but let's just kind of do that as we go throughout today. Okay, so one of the things we're going to start off with is the strategy state and observer patterns. And the big thing about these patterns is that this is probably like one of the kind of the first times you've kind of learned something that's like extremely theoretical in computer science, where it's kind of like you learn algorithms, but you can kind of like write the algorithm pretty much the same way each time, right? It's just almost like an algorithm is literally like a recipe, really. It's not that flexible. And sometimes like, BFS, right? It's always going to look kind of the same regardless of how you're doing the BFS, and stuff like that. So there's not a lot of flexibility in terms of how you apply the concept. The problem with patterns, though, is that patterns are entirely theoretical concepts. And so the application of that pattern can look extremely different. And so what that means is that when you're kind of implementing these patterns, there's not one way that they look. And it's sometimes introduced to as if they're like recipes or as if they're like kind of steps. And that's just to make it kind of easier, but it doesn't mean that they are. And the problem is if you kind of treat them as recipes, you can actually kind of inhibit their ability to kind of improve your code, and they can actually end up making it worse. Because what happens is either you misuse them or you kind of use them in some ways incorrectly, which means that your code ends up kind of becoming much longer, much harder to maintain, a huge mess, and typically quite a bit slower in the long run. And this is actually like a really big thing that does actually impact kind of real life, right? Is this concept of what is called over abstraction. I actually talked about over abstraction a bit last week, and it's, I think, the one concept that we don't talk about enough in this course, which is why today I kind of want to dedicate a bit of time towards it, and talk about like how can you recognize when something's over abstracted, and how can we kind of write code to avoid over abstraction. And so to begin, I actually want to look at the state pattern. And so the thing about the state pattern is it solves this kind of age-old question that we have. Let me just... There's no reason to have so many freaking notifications going on me. So the age-old problem is state is evil, right? This is just a pretty... I guess it's almost like... I really can't write today. Anyway, state is evil. It's pretty much just like the kind of whole, premature optimization is the root of all evil, that kind of computer science quote where it's a bunch of junk made by safe by people. It's pretty much correct. There's always kind of like some degree of, I don't know, finding a middle ground between the two extremes. And in this case, the state is evil one is kind of similar. So the idea of state is evil and the idea that state is bad in your system is nothing to do with state pattern, right? These are different concepts. But the concept is that state has two forms. It's either implicit or it's explicit. So really, when people are saying state is evil, they're actually referring to implicit state. And this concept of an implicit state is actually like pretty much what we call emergent behavior, kind of. And the idea of it is that, for example, I think the game of life is like actually a really great example here. So in the game of life, there's a series of rules based on the number of neighbors that a certain cell has. So there's two types of cells. There's cells that are like colored in, and there's cells that aren't colored in, right? And so based upon these number of neighbors, so whether or not you have too many neighbors or too few or just right, your cell will change. So for example, if you have too few, maybe your cell goes white. If you have too many, maybe it also goes white or unfilled. But if you have Just if, for example, let's say 2 neighbors, maybe you turn an unfilled cell to a filled cell, right? Because those 2 neighbors maybe like breed in this kind of abstract sense. And so when you kind of have this behavior, those are very simple rules. Those are very simple, explicit state transformations. But then you kind of get this like emerging behavior behind the scenes due to these interactions that kind of makes it able to somewhat simulate the certain properties of life. Like, for example, the idea that you could have an entity that kind of can move across the board or move across this kind of grid. Let me just show you a game of life animation, just for the sake of like seeing this stuff. And so like you have these very simple rules, and then suddenly you go from having very simple rules to having stuff like this. These are the same rules. It's just you get this extra behavior out of the system. And this is very analogous to like a real life kind of production database, that you have typically some pretty explicit state in your system, some pretty explicit set of rules. And then you have a bunch of implicit rules that no one ever thinks of. These are like hidden interactions. Oh, what if I gave a null to this value? What happens then? And someone's like, well, we always have that value. So we always have that value. There's no way we're ever going to get null for that value, right? And then, oh, well, actually, if you jump 3 times and press the right button and Mercury's in retrograde, then suddenly, the whole world explodes and, this thing is true. And that's actually quite common, is this kind of, is this concept of like emergent bugs, where you kind of have, and we typically do integration testing to kind of solve this concept of emergent bugs. It's this kind of idea that you may unit test a component entirely in isolation, that may be fine. But as soon as it starts interacting with other components, those interactions can form bugs due to how they interact, due to misunderstandings of the interface, typically. So the class itself, the unit test that you're testing, may be perfectly fine, right? It has a set of, it has a DBC, a series of contracts, designed by contract, that is. I was like, DBC, what does that stand for? I was like, design something contract. I don't know why I forgot that. Anyway, designed by contract. And then you go, okay, hey, you can't call this function null. And then someone does it anyway. And so what you do is you kind of get this like inherent bug through that system. And then rather than maybe it crashing, what happens is it kind of enters this like weird state where it starts like writing a bunch of corrupted files out. And then those corrupted files start affecting other systems. And then you kind of maybe get this like, almost like this kind of explosion effect. And like this stuff does happen. And when we've had production portals where we have like an entire system set up just get destroyed because a certain system that someone thought, oh, this is perfectly fine, this thing would never receive this input, got that input somehow, probably because of another bug. And then somehow it just started writing a bunch of bad files, and those bad files were read by the system. And then those bad files led to maybe, like, for example, there's many cases of bad files, things like the zip bombs, where you kind of get a zip that infinitely expands and stuff like that. There's safety things against that. But, you could have like just an invalid file that just causes like an exception to be raised, which causes the application to crash, which maybe causes something else to happen, and you kind of get this loop. And so these bad things can happen that you never expected. And so typically the point of removing implicit state is to try to shift away from this concept of emergent behavior and to make it so that every state transformation is extremely explicit. And so what you're doing is you're grabbing all the kind of implicit behavior, inside of it, and you're wrapping that up, and you're saying that belongs to this specific class, this state class. That's what the state pattern is doing. It's quarantining all the state to its own little box that nothing else can touch. And if it wants to transition to a different form, it grabs all the implicit state, everything that is involved in that component, and moves it with it. So what happens is you're basically able to kind of abstract state over multiple kind of variables. And I guess the best example of this is like a Boolean. So if you have a Boolean, let me just write it for goodness sake. Boolean. Okay, so if you have a Boolean, let's call this like is on. And this is like whether or not your light switch is on or off. And so if this light switch is on, the value will be true. If the light switch is off, it's going to be false. We don't need a state pattern for this. Don't implement a state pattern for this, right? There's no need to implement state pattern for this because it is already effectively, it's already got like an explicit state, right? Like the Boolean there is a state variable. It has explicit state to it. It has a defined interaction. It has two states in the system, and it has defined transitions between the two states. It is okay. It's all abstracted. It's fine. There's no difference between this and like state is on equals state dot off, and then having like state is off equal. Oh, let me just. That's kind of weird. There we go. And then we'll rewrite it like this. Just because otherwise it's like that weird double negative I hate. Okay, and then you have this like, okay, now I want to turn it on. And so obviously this is not really a transition, but maybe it's like turn on, I guess. And typically you have some kind of context variable that like holds the state, like the class surrounding the state object would also hold that, and you'd like, it's a bit more than this, but you know, you kind of get the point. You kind of get these two transitions, but these transitions is just underneath the scenes, just changing a Boolean. But let's say, for example, you had more than just a Boolean. Your light switch is connected to a power source, right? It's typically some kind of current that's kind of going through, right? So you have some kind of current here, and this current's kind of going through, you know, some kind of switch. You know, maybe you have like some kind of like latch switch here, right? And then this is maybe like powering some kind of bulb. I don't know. And you also have like some kind of battery here. We're not building circuits, but you know, like it's something like this, right? And so as you're flicking the switch, you're going to get this kind of latch to go down. It's going to complete the circuit, and electricity is going to travel through. And if you have a system like this, you have two things here. Like this movement of this latch could be abstracted as well as the actual position of the light switch. Now suddenly what's happening is you're kind of having this implicit state of the fact that electricity is moving through the system. So maybe in that case it starts to make more sense. So for example, if you have a concept such as you know, current, and it's just like, what is the current flowing through the system? The circuit's not complete, there will be no current. You know, there is no flow of electricity. But as soon as it becomes, you know, as soon as it's turned on, you're going to have some current flowing through the system. It's probably a double. And maybe you have some like measured voltage or whatever. And so what's happening here is you're able to kind of now grab all these like three different properties that you're doing and able to squish them into one, basically. And then you're able to kind of abstract what it means for that thing to change state and to influence the state changes within that. And so if you think about this week's lab, right, which you may have not seen, but this week's lab is like a kind of a SSO sign-on experience, right? And one of the things you have is this concept of a page transfer. So if I'm on page 1 and I want to go to page 2, if I'm selecting a login provider, and then now I want to log in, that transition there of which page are you on, it's not really necessarily a state pattern until you start to realize, well, what other state is there? Am I maintaining any other state? Or is there any implicit state in my system that is better abstracted by moving that code into another class, even if there isn't explicitly a variable for it? There may not be explicit data that's stored for that state, but the behavior of the system has changed so significantly that itself is almost like an implicit change in the system, right? And so what the state pattern does is it grabs these kind of changes and it kind of, again, quarantines them, puts them inside their own little container, so it's very clear how the system is changing over time. And so what you end up with, for example, you know, a classical state pattern may be, let's say, GitLab task board, right? I like this example, actually. So in your GitLab task board, what you have is you have like maybe a weighting estimation. So you have some kind of estimation column, right? And inside the estimation column, you have like a little card. And this little card is like, for example, implement. Let me just erase that for some reason. It's going to annoy me if I don't. And maybe you got like implement. I don't know. What's something you can implement? goals. Nah, let's do more funky. Fine, it's fine. Implement goals. So you have this concept of implementing goals. Someone's going to come along and go, oh, this is worth 9 hours, maybe. 9 hours of work. And then maybe it gets moved into the next step. Right? Now, you may not be doing this for your project because you don't really have to create user stories. But like, this is an example of like how you could kind of create this kind of flow. And then the next step may be like in dev. Okay, so now it gets moved in dev. I start working on it. Is there any state transformation here that has occurred? Can anyone tell me what has changed for this card? Is there any like property about this item here that has changed when I move it from awaiting estimation to in dev? So for example, let me grab an issue. This is not the right IPU. There you go. Thank you for doing this. But anyway, let me just edit this. And look on the right. So there's some items. Add a to-do, add a assignee, add a milestone, time tracking, due date, labels, not confidential, unlocked, participants, notifications. Is there anything here that will change when it goes from being estimated actually start being worked on? When someone says, this would take me 9 hours to do, or this would take anyone in our group 9 hours to do, and then someone goes, okay, I will go and do it. What changes between those two? Yes, exactly. Assignee. Who's assigned the task has changed. Now, there's other stuff that has changed as well. And the other stuff is the actual state of the item. Like, it's now in dev. It's now started work. So what you have is you have the concept of an assignee has changed, but also the state of the item, but maybe also implicit stuff as well. So for example, let's say you move it to the next column, and maybe the next column is like a review column, right? And this review column is for someone to maybe go and test it. Maybe people are going to code review your code and stuff like this. Now, this transformation, there's one thing that's required. What's required maybe for me to put the code into review? Do I have to do anything? Like, how is someone going to review this? Different assignee. Good. That's a good one. There's anything else? For example, you got the code needs to be done. Exactly. There's one other thing though. So we could have a call, and we could sit down, go over it, and we need a push request. That's what I'm talking about, a PR. A push, it's typical pull request because like you're pulling in the code into the main request. I think push request makes sense though. I think GitLab calls them merge requests, which is probably a better name for them. But anyway, you need some kind of request to say, hey, I've got this code that I want to put into the main branch. And this concept of like pulling this code into the main branch, that is, again, a requirement that's required to move into this state from in dev to review. So I could have validation on my states to say, hey, before I accept you, or when I accept you, I'm going to put an error on the front end to say, no, hey, you haven't created a PR. You can stay in the state, but I'm not going to be happy. I'm going to have a big red light for you until you fix this. You know? And if you try to leave the page, I'm just going to go back to in dev. So you have to go do that now in this page. And that's actually something that happens. I can't really show you an example because it's like kind of hard. I probably can, just because I would have to like set up a bunch of rules. But typically there's like rules. So for example, at my work, one of the rules is hey, before you move it in dev, it needs to have a dev assigned to it, right? Because we have like different columns, so like the tester that's going to test it, the dev that's going to dev it, and whoever's responsible for the product changeover or like the product manager. And so when you have a task like that, if I move it in dev without assigning myself, it's going to allow me to do it, but it's going to say, it's going to come up with an error saying you have to assign the dev right now. I'm going to then go and assign the dev, and it's going to then work, right? But if I don't assign the dev and reload the page, it instantly transfers back. So it's like kind of this concept of like a potential state transfer. It's going, I'm going to let you do this. But as soon as like you reload the page, it's going to revalidate and go, well, actually, this validation condition is not correct. I'm going to move it back. I'm going to undo the transformation. And then as you go through all the way to the end, you kind of get some interesting consequences. So, for example, one of the consequences that you could have is that when you move it to this done state here, it automatically merges the PR, it makes a build, it sends it off to your provider, maybe like, I don't know, Steam or however you're distributing the game. And then it sends out a Twitter saying new release. You could have all those actions that occur by just doing one thing. Now, that is what we typically call continuous deployments. Sometimes the part of that's continuous delivery. It depends. There's a bit of difference between the two. But typically, the idea of it is that you kind of have these automated steps as part of your process. And so these automated steps reduce the work that you have to do, the manual work that you have to do, and improve the kind of flow of the system. But are very hard to abstract if this is all just one big function. And so if I was looking at this and this is all one big function saying what do I do next, it's insane. I have to check my current state. Then once in my current state, I have a switch condition. I have to figure out how I'm going to change to the next state. And it just is like, even though you may segment it to different switch cases, and then suddenly now you need to go have the ability to validate. That's another series of switch cases. Oh, and then now you also need to do something else, which is the fact that what I just said about actions. Once I move it to that state, I want to perform all these actions. And so now what suddenly in your switch cases, you're causing all these random different actions, and it's really hard to know exactly which class is causing which actions because maybe you just have a comment above each switch case. It's like not very clear. And every time I have to add a new option, I have to add a new case to the switch case, right? And maybe everything's using strings or enums or something crazy. Like, it's not clean. And so what a state pattern does is takes that concept and goes, oh, okay, sure. But let me just kind of grab each of these kind of cases inside the switch and move it basically to its own class. That's all it's really doing. And so I think there's a decent enough example. Let me find it. Okay, and so what I'm looking for, so many, I got lost. Source. Yes, does this have the what I want? It does not have what I want. Kind of, but not really. Yeah. Okay, so I'm just gonna come off our own example. We're actually just gonna build this task board straight up inside some kind of code. And then I'm gonna show you how strategy pattern can come in and add this. This is kind of on the fly, so we'll see how this goes. Like, I have not planned this code to be adding. I was just like, I'll come up with an idea. We'll be good. Okay, we will see. So I'll have a GitLab class, which is going to be like my context. And we'll give this a package. And we will add the source. Okay, and okay, and then we have this next concept, which is, hey, we need to kind of manage this internal state. So let's add a bunch of states. So I love creating an explicit state kind of package for us. And then I like chucking the state in there. And typically I like using some kind of abstract class. Doesn't really matter. And then what I'm going to do here is I've got an abstract class state. And what I'm going to have is I'm going to go, okay, light bulb moment. What do we need? What do we need to store inside this state? What does every single thing on this board do? Well, they all have an assignee. Which I think is double S. Yeah, that seems right. I don't know why my brain's right failing on me there. Is there any other state that everything has, that all of these right now have? Anything that they share? And while you think about that, I'm just going to start writing some other classes. So we're going to have the concept of a card. And then this card will have a current state once it decides that it wants to let me do that. And then my GitLab task board will have, I'm just going to like, not hard code the states, but like I'm just going to like say the state is this exact format here rather than like doing some kind of configuration thing because I don't want to do that. It's a nightmare. So we're just going to have like a list of cards. Okay. And so the idea of this, and this will actually even have observer, by the way. Like this, I think. I don't know. We'll see. I could probably check an observer example. They did not override. There was a production issue. They didn't follow the instructions. Oh well. They should be able to solve that. Okay, so it's hard to get people instructions sometimes, I guess. So we have the state here of what current state the card is in, and then we also have this concept here in ArrayList, which is like, well, I don't explain ArrayList. Okay, so we're just gonna have all these cards here. Then we're just gonna have the idea of like adding a card, I guess. I'm probably just gonna, let's just hard code the cards. Why not? This is a good enough example as is. So what we'll do is we'll just hard code like adding cards to this list by just using this main function here. Like we don't have to abstract that out. You know, there's no need for that. So obviously we have assignee. The other thing I think that's really important is this kind of concept of like maybe time tracking, right? So total time. So this is the estimation that you originally came up with, right? So in the beginning, this is going to be 0. But over time, as you have an estimation, it's going to go down. And let's generate constructors, select fields, done, public id time left, return time spent estimation mod minus the time spent. I don't really care about getting these two values, to be honest. I mean, I presume in a real system you do, but it's fine. Spend time. Hours. This total time spent is possibly good hours. So what you're doing is you're just kind of writing some basic kind of structure here. Getting the assignee value probably makes sense, right? And so, oh geez, I cannot hit keyboards. Okay, there we go. And there's our getter, and so we get the ability to get. Why would you have a setter for this? No, actually, you know what? That makes sense. Sure. Okay, you can set the assignee. And so now you have this ability to change who the assignee is. You have the ability to see the assignee. That makes sense. Okay, what's next? Well, a lot of these state transitions, they don't actually have to be different classes, right? And so this is actually what's kind of, I think, a really unique aspect of writing states, is that you could actually kind of abstract a lot of this stuff out. But the requirement for each state is important. So the requirement is that for this object to leave this state, it needs to have some time value that's greater than 0, right? Because if you're assigning an estimation to it, it's got to take more time than 0. Like maybe 30 minutes, maybe 2 hours, maybe whatever. But it's got to take some time. So what we're going to do is we're going to kind of represent that. Now, you could represent that differently, and we can kind of talk a bit about that, but let's just try to keep it simple. So what we're going to have is we're going to have the concept of a validation on leave and a validation on enter. Just because I think that's going to help us abstract this a little bit better. then normal. Depends whether or not you want to use exceptions here. I don't really want to use exceptions. Let's just create this concept of a validation error. And I don't want to call it a validation error anymore. I decided I want to call it validation. Okay, so then I'm going to have some kind of like Boolean that says like is error. I'm going to have like some kind of string that's like the error text, and that's good enough. And then I'm just going to create some static functions to create this validation. Say that yes, this is okay. Return new validation. Create a private constructor, right, for these two values. Now, I quite like this concept of a private constructor here and public statics. And this is actually something I wanted to talk about previously, but I really didn't have time. And so I'm actually going to talk about it now as well. So let's just do false and null here. So the idea of this is very often we kind of want to do a bit of validation when we construct objects. That's quite common. And so, for example, we want to make sure, oh, hey, you want to go and construct this enrollment object, we got to make sure you're enrolled, right? That's a common thing that you found in previous labs like lab 4 or lab 3, one of the two, of like, hey, let's validate this enrollment. Let's make sure that this is like okay that you can enroll like this. And I guess I don't need an is error. And so what we're going to do is we're just going to say, okay, sure, we can do the same thing here. But rather than having to throw an exception in the constructor, what you can do is you can abstract it around the static class. And so what that means is it's very convenient to still call the function because it has a return value that you can decide. And so that gives you this kind of really nice flexibility to it. So for example, you could return null if the enrollment failed. You could return this kind of object like this validation object that says like enrollment failure reason, and then also contains like an enrollment object if the enrollment succeeds. So it's like a what we call like a either class, like either value or not a value, right? There's often classes called optionals that you can do the same thing. That says either this will return a value that is correct or will return nothing. So this kind of concept of an optional is very cool in Java. And I think what you'll find is it's kind of quite convenient to kind of call these functions. And it feels very nice because you can just call them like normal functions. And they have values that return. So for example, rather than writing a bit of code that looks like this, you'd say, for example, I want to create an enrollment, new enrollment student. Oh, okay, you could throw an exception. Try catch. Catch enrollment failed. Enrollment exception. And then you would have some kind of exception here that you could put. Maybe, I don't know why my brain's like, don't write it out, just write it out. Anyway, and maybe you like do something else. So maybe you just like rethrow it for no reason. I don't know. You like log it or something. Like this is inconvenient because suddenly now you have to put everything inside this try catch, which sucks. So now you're like, okay, well now I can't do that. So now I have to write it this way. All right. It's a lot of lines of code just for creating a new enrollment. This kind of way, if it returned null and you're happy with null, it would just be try enroll typically. Oh wait, does it exist? So much nicer. If you want it to like have some kind of optional, you could do something like this. You could like, okay, I don't know, like dot. I think it's called like if present or something. And then you can like bind a lambda. Yeah, I was right. It is the if present. The curse of Wait, why did I write it that way? My brain is like not parsing that correctly. Anyway, so if present, if it is if present. Anyway, so try to involve this, and then if it's present, run this lambda function. Yeah, I think it's if present. Oh no, if present just say something. I don't know. I can look it up. Java is a pretty bad optional class, so it's not particularly nice. If present, yeah, no, if present does check consumer. This is still correct. It has an override for it. Map is the other one I was thinking of as well. A map is so nice for optional. Oh, the beauty of map. Like you can do some really nice stuff with optionals. Like I think one of the best examples is I have this optional class I wrote at one point, which I needed to do because like I had this concept of like a bunch of like children resources to a parent resource. Wait, I got a message. It's important. No, it's not important. I get. And so these children resources to a parent resource, I need to manage this properly, right? And so the way I'm going to manage this is I need to have some way so that once I load the parent resource, I then also apply it to all the children resource. I do the same kind of action. And I also want to do it so that if one of them fails, I kind of still try to do the rest. And so what I end up with is I kind of end up with almost like a kind of a series of optionals that like has true or falses and stuff like that. And so it's actually really cool. You can kind of abstract this behavior really simply. Otherwise, it'd be very, very complicated to write this kind of code where you have to load a parent resource, and if that loads, then you have to load all the children resources, and you have to kind of aggregate all the ones that succeed. If the ones don't succeed, then you would have to grab the ones that don't succeed, and then kind of abstract that out as a failure reason with including the ones that do. And so it's kind of like multiple nested for loops, and the children resources can also have children resources. You kind of get this inherent kind of recursion behavior behind it, and so it's kind of very and so I think one of the really nice things about like some of these classes is that you get this kind of functional kind of property of it. Java's not too great at this, but it still does it pretty well. And so for example, you could be like, hey, I want to load a kitten from the internet, and then after that's loaded, after I load the kitten correctly, I then want it so that I want to grab, or maybe it's like load URL kitten.org/kitten. I don't know. Hopefully that's a website that's somewhat reasonable. And then I'm going to map that to some kind of download. So I'm going to say, once you've loaded the URL, this is a magical API, by the way. I'm then going to map it and say, okay, I don't know, HTTP request, read as body, read body. Typically you have like an async here, but sure. Java doesn't really handle async that well either. And so what you're going to do is you're going to read the body. And so what will happen is it will load the URL, and this will return a value of, let's say, for example, HTTP request. And this request will have maybe some kind of content, right? And then when you say read body, now it's transformed it from an optional of HTTP request, which is kind of a funky optional, I guess, to an optional of a string, which is the body. But maybe I want to read body as like bytes, because I kind of want it to be an image. Read body as bytes, so now it's some kind of like byte array. And then now I can say, okay, now I've got this byte array. Now what I want to do is I want to construct an image from that. So I should be able to do something like maybe like image load. And so now what's going to happen is it's going to go and load an image from those bytes if it exists. So now you get an option of an image, right? And the problem about each of these is each of these would have individual error cases that you would have to check. And by abstracting it as an optional, you kind of, rather than having that really complicated nesting where you have to go, okay, check if the image loads, like run the function, check if the image is valid. Yep, okay, if it's valid, now you have an if statement inside of that. Then you have another if statement. You know, it would look like something like this. Right, and then you would have to say like if request is success, right? Honestly, HTTP request could just like inherit from optional, I guess. Anyway, or like have some like interface of optional. Doesn't really matter. So if the request is successful, then what we want to do is we want to say, okay, now we want to read the boy's bytes. Request.read as bytes. And then you would have finally like the image. Oh, but it's only if the body is not null, because maybe like it's null in some cases. And then you would have to read the image. All right, and then finally, if the image is not equal null or some validation on the image, return image. And then otherwise, if any of these cases fail, maybe you actually want like an error message, right? And the thing about optional is it doesn't support error messages, but there's other classes that do. There's other classes that you say, hey, this either has like a real value or has an error value, right? And in Rust, they call them results. And the idea is like, hey, this has like a real result or it has some kind of error. And this error could be like an exception class or it could be some kind of enum or something like that. And so the idea, I mean, not really exception class, but anyway. And so the idea of this is that you kind of get this behavior here with all these else's, but like as just a series of maps, right? So I think it's quite convenient. Anyway, so what happens here with these validation functions is that we kind of get a pretty nice interface to call it without having to like have this weird thing where, oh, if you call this function, you pass a null, then it's successful. And if you call this function with a default constructor, it's always successful. Like that doesn't really make sense to me. I kind of like the names that explicitly say, oh, okay, this is exactly what this is. And so, for example, we'd have a function here which has like some validation to it. And this is, for example, pre-move. Like before I move this card or before I action this card, validate this. Or maybe we just have like an is valid. I don't know. Is valid probably makes so much more sense. And it's abstract to nobody. So, hey, is this object valid? That's all I'm asking. Is currently in the state it's in, is it valid? That's it. The joys of having to manually import stuff because it doesn't like me. Yes, that's what I meant. Okay, so we have this validation here, and that's all good. Now we have estimation card. This is going to extend from our state. And then what we're going to do is we're going to have this make this implement our state pattern by checking the validation. And then we also need probably some kind of like, I want to move from this state. Where do I move? Now, the thing is, there may be multiple valid states. I may be able to move from estimated to done. Probably not. I may be able to. And so I'll kind of like leave that up to you for how you can think of like how that could be done. And an example would be like return a list of possible types that you want to transition to, and then you can like say, oh, I want this specific transition, like maybe like a list of strings or something. Like, hey, here's all the different states I can go to, rather than just like move. Okay, there's my nice function. Here's my isValid function. Now I am going to separate the concept of isValid and move. And I'm just going to do it like this, just for the sake of making it slightly cleaner. So this is going to have a function called next state, and you see it's private. And then it's going to have a function called, I guess this itself has to return like its own object. Yeah, which is why it's kind of clunky to have this like, it's not necessarily that clunky because in moving it, the estimation will change. Okay. You know what? It's fine. We'll keep it like this. We may want to change some things. Anyway, but for now, I think it's fine. So we're going to have this concept of next state. One of private or protected. Oh, wait, this should be protected. What am I doing? And then what we want to do here is we want to go, okay. And the reason why I'm making this protected, not public, is because I just want states to be override this. And this is like internal to this class. It's like almost like an interface kind of. And then I can maybe add like a function here called like, I don't know why I keep doing that. Validate. It's kind of clunky because it's like I don't want to do generics yet. So normally I would have like a wrapper for the object. Maybe it makes sense to have validation throw as an exception. Just because it will make the code cleaner. Or I just throw it as an exception. Let's just do this. So we'll just say next state. And if it's not valid, it's just going to return itself. And then, sorry, move to next state. Or try to move. That's the wordiest ever thing. Try to transition. Try to action. I don't know. Can't think of names right now. What's a good name for this? Attempt to move card. Sure. Why not? Good enough. It's fine. So what this will do is this will just be like, hey, if the card is valid, return the next state. Otherwise, return this. Right? So then you have this kind of concept of this transition. And if the card isn't valid, I need a function on this to say whether or not it's valid. Okay. The validation is valid equals this. That's kind of funny how that works. Anyway, if it's valid and I need like a... I'm really going to write it like this. Okay, it's actually really funny. We've got a result. Is okay. If validation is valid. That's really funny to me. Java is beautiful. Oh, don't ever mock my Java. Is okay. Return error text does not. Error text equals null, I guess. Yeah, sure. Yeah. At least I'm not creating factories for my validation class so that you can write like 100 lines. Which is real code that probably exists. I think the worst ever code I ever saw for Java recently was I was helping a friend code something, and they were like, "Oh, I'm gonna follow the right design patterns," and they decided to like follow YouTube, which is probably not always the best idea. And they had like 20 classes just to do something that was like probably like 10 lines or 20 lines of code, and it was really confusing mess. And they literally had like a factory function that was like a generic, and this factory function took in two things. Like there was like a class, and it was a class that took in like what you're trying to construct, and like a generic abstract constructor for that construct. So construct. That's yeah. It was, I don't know why. Anyway, so what you had is you kind of had these like this weird concept where you had this like class of this, so then this would be like some kind of factory, and so you'd have like some random like create function here, and you'd like give it the two things, and then okay, now I want to actually create something. I want to now do this, and I was like, my lord, what are you doing? It's like over abstraction. It's just like it's crazy. It's really funny. Anyway, let's keep going. So we have this main list here. We have this card is okay. We're actually getting to the point where we can write real code, and I'm not getting too distracted. As I said, so check saying, yeah, it looks better. Okay, good. Okay, so the next thing is this concept of the state transition. And so the concept of the state transition is, okay, are we valid in this estimation? And this is really easy. This is going to be if total time left is greater than 0. Now, I am saying time left here. Sure. Otherwise, validation. I feel like I kind of over abstracted the concept of validation there. Like, I didn't really overdo it, but for like an example like this, I probably didn't need like an entire validation class. Like in reality, you probably would, but not like this. Anyway, that's okay. Needs an estimation. So I am doing time left, which will include like, let's say you add a bunch of tasks, and then you assign an estimation to those tasks, and then you like tick off all the tasks you're done, you have no time left, and then you move it back to estimated. To move it from that state, you wouldn't be able to without adding extra time to it. And like in my head, that's okay. Like I'm happy with that happening here, just because in my system, you can't move back to estimated. That's like one of the things I'm saying. So what you can do is you can move from review back to in dev, and you can move from review back to done, but you can't move at any point back to rating estimation. If you wanted to, you would need to like probably have slightly more complicated code here. So, let's just keep that in mind. I'm kind of roughly just showing an example of how this stuff works. And so what we have is we have this concept of, okay, we have this next state. For my estimate card, it's always the same next state. And so this is just going to be, okay, return new, and we need a new card for this. And so this is just going to be in dev card.java That's what I meant. Let's just change the name while we're doing that. State. Easy. And it's kind of funky, I guess. So the next thing I kind of like about this idea is actually to completely ditch this concept of attention move. And basically just make it so that every class can every like card itself can define its own like validation for the next move, because I think that just like kind of makes more sense. So for example, this would be called like estimate, and then you'd be like, hey, here's the hours I want you to estimate. And then what it would do is it would then literally return a new card of dev card and say, okay, I've estimated this card, now let's move into its next state. Let's just move these. And this card here would basically take in the assignee and stuff like that. So, hey, you want to move it to int hours, you estimate it. You also need to assign some other things to it. So for example, for estimation, I actually think it makes sense to just change the current one. And there's no need to change the current state. So this just can be public. Okay, hey, you want to estimate this, you only estimate in this state. Sure, that's fine. It's a little bit funky, but why not? And I guess we could add like a variable for this. Give a negative time to a spend time. That'd be kind of funny. Yes, you could represent it that way. It's fine. And we'll just like have like set estimation. This dot total times estimation equals hours. And so what you would have here is you would say, okay, I want to estimate this. Okay, this dot set estimation. And I'm going to set my estimation to be that many hours. And then what I'm going to do here is then I'm going to go, okay, cool. Now I've done that. Now I can have a function, right? Which is going to be called attempt. Actually, I'm going to add back what I just had. I am flip-flopping between too many ideas. I should have thought about this. Let's go. It's not too much. I just like the concept of move, but I'm going to add the concept of stuff to this as well. I'm going to do both because I think it actually will make it cleaner. Anyway, so we have this concept of is valid, and this can have an override on it. And hey, you want to move to the next state? Cool. All you gotta do is just return new dev card, and this new dev card. I probably could have like a cloning thing. I'm just gonna manually do this. I don't really know. We'll just do it this way. But the problem is you want like different assignees. It's like clunky, you know? This doesn't feel right. I know exactly what I want to do. We'll clean this up. Okay, so what we want to do here is we actually want to do something slightly different. If we're going to move a card, we want to take like in some kind of object that the class itself is going to understand. And so I'm actually going to refer to it as like object. And I'm going to say this is like what I'm attempting to do. So this is like kind of some kind of parameter. Now, in reality, this is actually pretty common. It's probably not necessarily always an object, but it could be something similar. Like it could be like some JSON object, some configuration file that's saying, okay, I'm attempting to move this, but I've also created the PR. Like this is like kind of the system set up. And so when I'm validating it, I can actually pass this into both. And now this starts to make a little more sense, I think. I'm also going to add a getter for the estimation. Okay, or not. And a getter for time spent. Now, I probably, if I was to oh, wait, this is meant to be ints. If I was to really think about this, I think I would probably grab these kind of properties and be like, okay, the only thing that's really changing is assignee. These can kind of be properties in the card, and then state can just change the card rather than having this kind of carry-on effect. But I think this is okay. I'm not going to worry about it too much, because time-wise, we're going to finish up in the next couple minutes. And so what you're going to do is you're going to have, okay, I have this thing. I'm going to take in this state, and then this can validate it here. And so can this. Okay, sure. But if you're going to validate it, sure, yes, I need a new estimation, but I also need something else. And so I'm going to add this concept of and to this. So now I can combine two validation objects, almost like kind of like I guess kind of like a optional. So if other dot is okay and this dot is okay, I guess I would just write it like this. And then we can just do like maybe, I don't know, like a new line between them. You could do something more fancy, I'm sure. So what we have to do now is combine validation objects. And so now what we could do is we could have something inside our estimation card, and it could be like, hey, this needs to be true, right? And this also needs to be true. And so what we could actually do is we could actually kind of probably abstract this concept out a bit better. And we could have like a public static if validate maybe. And so you could have like some kind of Boolean here, which is like condition. And then you would have like if error. Which could just do our kind of typical thing. Else error, if error. Okay, and then our estimation card can look a bit cleaner by just doing a validation.validate. And the validation condition is time left is greater than 0, and the error message is this. Okay, and then we could just combine this with another one, which is like validation.validate, and this would be like, hey, the param has to be a type of a string, because this is like you assigning, right? Again, you could probably have like an assignee object here that's a bit better abstracted. That's okay. Needs an assignee. This is actually pretty similar to how validation is actually done in some cases, because you kind of have these like different concepts. So then you kind of like have, okay, if I want to validate these are all the validation concepts that exist for this object to close. And so you kind of like, I don't know, separately validate them like this. I don't know, doesn't matter. So then the next state is just going to be pretty much just clone. I guess you could add a clone method, but it's fine. I don't remember what I need to pass to this. Time estimation and total time spent. Okay. There we go. So then now we have this card done. So what we have is we have this ability to assign estimation, and then we have ability to validate estimation and ability to move to the next state. And then what you could have is you could have this concept of a previous state as well, right? If you really wanted to, or hey, I'm in my review state, I can either go forwards or backwards. And that's okay. You could add validation for both ways. You could kind of add this concept of here's every option I can choose. I can go here, I can go here, I can go here, I can go here. These are the ones that are valid. These are the ones that wouldn't be. Okay. So you now have this ability, okay, I've assigned it. And when I move it to my next state, I have to give it a new assignee to move it because that's a requirement, right? And then maybe when you move it to review, it needs a new assignee. And then maybe when it gets moved to done, it needs to be past like the ID of the pull request, right? Something like that. And then you could be like, hey, go and look at that pull request. Is that pull request completed? No, that pull request isn't completed. Okay, it's not done. The validation has failed, right? And so you can kind of break it down. So let's just kind of keep this as this kind of somewhat abstract object here, and we'll only spend 10 more minutes on this, and we'll be able to cover the strategy and the observer stuff pretty easily through this. So one of the things I want to do here is, let's say, for example, to send an email every time a state moves. But maybe I want to send a push request, maybe like a SMS or like a notification, right? Like a iOS notification, Android notification, these kind of like pop-ups. They're called push notifications. And so what I really want is I really want something to consume this kind of state action. So I could have this function on this class that's called public void register action listener. Hey, every time I move and perform an action, I want you to tell me. Right? Okay, cool. Should it exist in the card? Probably can exist in GitLab, right? Okay, add that. And so that means every time you go, hey, I want to go and move this card, GitLab goes, oh, sweet, I have this action listener that's going to trigger every time this card's moved. Okay, sure. And what you can do is kind of this really clever thing that I quite like, which is where you can actually have interfaces that kind of inherit from each other. And it's kind of complicated, but I actually think it's worth doing. So, well, I'll just kind of briefly show that kind of concept off. And so what you could have is you could have something called like an action listener. And so the typical way this could be represented would be like, okay, this is an interface. Hey, you want to come here? You want to listen? Go ahead. And my action type is here as well. And the action type could be, for example, card moved, validation failed. Stuff like that. Like I tried to move the card, but the validation failed. Send an email. I tried to move this from someone literally picked up the card and moved it to review, but hey, I can't move this thing to review because the or unit test failed. We have like unit test maybe automatically running. Maybe you set that up, right? So now you send an email to both of them saying, the unit tests don't work, or the unit test failed. Okay, sweet. Okay, then that's why I didn't move, right? And so you kind of remind people or whatever. And then you would maybe have some kind of function here that is like, I don't know, on action, right? And it says, oh, this is the action type, and maybe there's some kind of like, this was the card that was moved. Maybe you give like the two states, like this is, I guess you can already read that from the card. I guess you probably need like the old state, but like sometimes it hasn't necessarily moved to an old state. Some hasn't necessarily moved to in state. Like the problem here is like each of these depends on what you're trying to listen to, right? So if I'm trying to listen to whether or not the card moved, I care about the previous state and the current state. That matters to me. If I care about validation failed, right? I probably just want to know why. I want to know the validation error. You don't get that with this. And so there's a few ways you can do it. One of the ways is having this concept of inheritance where you kind of have this action listener, and then you have like inherited interfaces that like add the ones. But the other way is this really new method actually, which I'm going to show off instead, which is called default. And what you can do is you can provide default bodies to all these functions. And so this is, for example, on move, right? This is the card, and this was the previous state. And you can read the current state from the card itself, maybe. I don't know, doesn't really matter. And then we're also going to add another one, which is called on validation failed. By the way, hint, hint, this is quite useful for your project because doing stuff like this could be quite useful if you have a ton of events you want to listen to, maybe. And this is the card, and this is the validation, right? Or maybe you literally want to trigger every time a validation is even attempted, right? Like, opportunities are really nice here. You go and you register a listener. Okay, so this dot, so I need an action listener here. GitLab. Right, and then I can say GitLab, hey, I'm gonna go and register a listener every time you do something. Okay, sure. And I want to create a new action listener. Oh, I need to do it like this. Okay, cool. And then what I want to do is I want to override some functions. What do I want to implement? Well, I want to implement on move, and I want to implement validation failed. That's pretty cool. There's no need for me to call the super function because it's a default, right? And so I could literally say, okay, sure. Maybe this could even like have a validation on it that says, hey, I have some external validation I want to do. So, hey, when you're checking for validation, you also have to run this and check, right? You could like kind of have like external overriding of functions effectively, which is actually pretty cool and nifty. But you know, it could just be like a system.log here, right? Moved to new state, right? And you could like add a bunch of variables saying, oh, what's the state name and stuff like that. And this could be like, I don't know. I guess there's no way to like read the error message in the validation class. Maybe it's like, I don't know. Maybe you could have like a blog function. I guess reading is error message. And you could throw an exception here, like if it's already valid. Like, hey, there's no error message. Why are you trying to get this function? But I don't really think it matters. There we go. And so what you have here is you kind of have this very basic mock-up of a kind of a GitLab system where you're able to kind of register actions, move cards, you're able to observe events, you're able to kind of think about these different things. And in some ways, this awfully looks like a strategy pattern, right? I'm executing different strategies based on different requirements. It's just I'm doing them reactively. And I mean, this again was completely unplanned, but it kind of turned out nicely. And we'll create like action listeners here, like listener secrets, new action listener, new array list. And then this would be like listeners dot add listener, and maybe I like some kind of trigger event here, right? But what you have here is you kind of get this like nice thing that I've been seeing from the start of today, which is, hey, patterns aren't recipes. Patterns don't have a strict formula. There's no kind of, you always have to do it this one way. And what you end up here is you kind of end up with a strategy pattern that's kind of implemented inside of an observer pattern. And so what's happening here is not so much for these kind of very clear observation events, but if, for example, if you did what I said before, where you go, hey, no, I actually want to override or change the validation. And I'm going to externally validate this card. By default, it's good. There's no external validation. Then for me, I come along and go, oh, I'm grumpy. I don't want anything to ever move on this board ever again. Right? Everything's failed. Everything's going to blow up. Right? And so this is actually changing a strategy. You're changing how you're going to approach something based upon some kind of condition, right? And the condition is what action listeners you have registered, right? And that's kind of what's changing the system. That's kind of what's changing these kind of concepts here, right? And so there's better examples of strategy that I think are probably much more kind of realistic, but this is a decent enough example here. So like a better one, just for the sake of it, is obviously like there's one in the Tute this week with like the restaurant. I don't really like the Tute this week with the whole restaurant thing. So but in this case, the one thing I did kind of like was this kind of concept of GitLab, I guess. But also, if we bring this back to the project or the assignment, actually let's talk about assignment. So in the assignment, right, you had many classes, hopefully, that, you know, like your various satellites. And you have this kind of maybe this issue that kind of came up where you said, hey, I have a file that could be compressed. It could be compressed via zip. It could be compressed via quantum. Or it could just be uncompressed. How am I going to represent this state here? And now you could represent it through a state pattern, right? But it's not really a state pattern because you're not really transitioning from quantum to zipped, because you could be technically both quantum and zipped, right? And we'll actually learn later on, this is something called a decorator, which is basically where you can kind of nest objects on top of each other. You didn't really have to do that for the assignment because we told you didn't ever have to handle quantum and zipped at the same time. So this is, that's one of the reasons we don't, make it so you have to use a pattern, right? But if you needed to do that, a good example would be decorator. But there's another example, which is in your assignment where you didn't have to do that. What could you have done? Well, you could have just had a very simple file class that had on top of it, which is called some kind of provider, like a content provider. Like, hey, I'm going to give you the raw input to me, and you're going to give me what that actually translates to. So, for example, you may need more than that. You mean like the total bytes, right? Something like this. And so an example here would be that this kind of provider could say, okay, hey, I'm only going to unzip once everything is downloaded and you're on a device. And that's when my content's going to change. That's when my strategy is going to change. So by default, the content provider for quantum and zipped, or it's just to show quantum, right? Because quantum is something that most people would have done. So quantum is, hey, the file content's basically always the same, except for when it's fully downloaded / uploaded onto a quantum satellite, in which case it gets quantumly compressed and the size of it gets smaller, right? Okay. And so what we have here is we have this interesting kind of result of this, which is, okay, the strategy starts off being just maybe my normal strategy, which has the normal strategy. By the way, your strategy functions can have multiple functions inside them. They kind of should, maybe in some ways. So maybe one function's like get file size, and this is just going to return the total size. Maybe this is just going to return like the current size of the data, which is just going to be like data.length, right? And then get data, maybe like data size, I don't really know. And this is going to return data. And then once it's fully downloaded or uploaded to the satellite, then your strategy changes. And now suddenly the file goes from being normal strategy to being a quantum strategy. Now every time you ask the file, its size is, data, like quantum in data. Then it's going to be data.length. I don't know. It was like minus, it was like 2/3, I think. Sure. Kind of funky, but that works. And then the get data is just going to be data. And then you have a zipped strategy, which is the same thing. Hey, I want this content to be zipped. Okay. And maybe it like internally stores the zipped file as zip file. Zip data, maybe. Just so you don't have to zip it each time. Just, I don't know, some semblance of performance. Right? And then you go, oh, now I want to unzip it. And then it would be the same thing, but it's just going to be like data. And data. Right? And so this is okay. I mean, I guess you could do it this way. But you'll probably notice something. And you'll notice that especially it's more kind of important for zipped and unzipped. It changes from zipped to unzipped based upon a very specific condition. It's a transition. And so it transitions from zipped to unzipped based upon when it finishes transferring to a device, which guess what also happens to quantum. So what you could have is you could go, you know what, none of these have to be strategies, they can all be states. And so what you've actually found here is that often state patterns and strategy patterns are actually quite similar. People get very, very confused over the two of them, funnily enough, because functionally they kind of solve the same problem. What they do is they say, hey, you have all this behavior that changes based upon some circumstance. Or you have a game mode, and based on that game mode, behavior changes in your game. Now, strategy pattern is entirely focused on the behavior changing. Typically, when you have data changing like this, sometimes it's better to represent a state pattern because the data is physically changing. But you don't necessarily have to, but it's great when you have these transition points. So now what you have in each function, you now have a transition. And so this transition is maybe now triggered by the satellite. The satellite kind of chooses which thing. So instead of being on the states, what you'd have is you would have like on the satellite, like on the quantum satellite, it would have a get file state. And this could say, oh, wonderful. Okay, I just want to return a new quantum state of my file. And this gets triggered once the file finishes uploading. And then suddenly this file state gets passed along. And again, you could use decorator of the states to get that nesting behavior. And how decorator works in this case is that each object would have like an inner. So for example, the quantum state would also have like inner. And then when you ask the quantum state about its internals, it would say like, okay, I have to first get my inner data size, right? So it would look something like this if you're kind of doing like a typical nested state pattern, right? Your base state would look the same, but this would, instead of saying inner, it would be inner.getData, right? Because the inner may want to manipulate that data in some way. It may want to zip it, unzip it, whatever. So if you have a zip and unzip, the zip will zip the data, then the unzip will unzip the zip data, and so you end up with just the normal content, right? But you kind of get this much more explicit layering, and this would be like inner.getLength. Am I? Oh, I am. Just then? That's funny. Okay. I don't know how I did it. Did I do that? I must have pressed some button. Did I miss much of what I was saying? Or was it just like 1 second or something? Okay. Like 10 seconds. Okay, sweet. So what I was saying is you kind of have this like nesting of like the inner object, right? And so what happens is you go, hey, I'm quantum state. I'm going to go talk to my inner object, which is going to tell me what's happening. Okay. I think that's kind of, yeah, awesome. I think that's pretty good as like kind of a wrap up, and you can kind of say, oh, in the assignment I could have done all this stuff differently, right? And I could have had all these like different states, and I could have done all these kind of more complicated logic, like, you know, I could have kind of represented like this or like this and stuff like this. And so typically kind of the way I would write state patterns and stuff like that, I think observers are typically pretty obvious, but state and strategies are kind of harder, is you want to not overuse them because they will just make your code worse. State pattern, I would actually say by default, has a negative effect on the code. And so you actually need to get quite a bit of benefit from it for it to be useful. And the negative benefit it gives you is by the complexity that it brings. Now, a typical state pattern is not that complex, but they can get very complex. And so what is quite useful is if you actually have, let me just the inner.getData here so it doesn't annoy me. Is if you actually like start off and go, I'm not going to necessarily use a state pattern or a strategy pattern until I see a code issue, until I see a design issue. And so, for example, I don't want to talk about the project too much, but the assignment I could actually talk a decent amount about. And so you go, okay, you know, like this is an example of a state and strategy pattern. You don't necessarily have to start off with this, right? You start off with just one file class, and then you get to quantum, and you're like, oh, I can still just have a Boolean that says whether or not it's a quantum. Like, that's still fine. right? Because it's only while on the device. Or maybe you just have like an override on the satellite itself, and the satellite itself decides on the size of the file data. That solves all your problems, right? And it's only when you get to zip that you start to go, okay, now I need to pass this object around. And even then, maybe you start off and you go, I don't need to go state pattern fully yet. Let me just create like some kind of zip object to represent it as I move that zip object around the system. And then you look at the specification and go, do I need this kind of relationship between zip and quantum? Do I need them to be somewhat involved? Or can zip file just be a subclass of file? And does that just work? Right? And the answer is it probably just works, because even with this decorator, you only have two levels. You only have is zipped, basically, and is quantum, which means that like in quantum only matters in the satellite. So if the satellite's able to override the size, then technically they would still interact well if you just had like a quantum subclass, that kind of a zipped subclass file. So if you had like a zip file that inherited from file, and that gives you kind of all this extra zip behavior, and you pass that around, you would get pretty much the same behavior. And it would pretty much function the same thing as this. I would say this is actually cleaner. And it's only cleaner because it's able to kind of represent, like the satellites can kind of choose which state, and it probably makes it a bit better to kind of transition from zip to unzipped. But this probably also works just as well, and it's probably less code. So it's actually, in this case, they're probably about even. And it's only really because of that nested behavior that state kind of wins here. If state didn't need this kind of nested behavior here, it probably would be much easier just to do this, where you kind of have this different class. And so it's sometimes like a bit of a toss-up, right? Otherwise, you're like, I don't actually know if this is going to be beneficial to the code or not. Anyway, let's jump into the lab. It was a very different shoot today. Okay. To T1, T3. I guess I'm going to go staff repos. And then lab 5. Okay, so there's a video that goes through lab 5, by the way. It's on the announcements, so you can check that out. As you can see here. And the video will cover basically what an SSO is. So I'm not going to cover it here just because it's just a video of me explaining what SSO is. But roughly all it is, I guess I will cover it. As I say, I wouldn't. You basically visit a website, as you can see here, and then based upon a series of kind of conditions, it changes how you kind of connect with that website. So maybe you already have logged into that website, so you automatically just log in. If you haven't logged in, then SSO kind of kicks in. And it goes, okay, I have these series of credentials for all these other websites. Which one do you want to use? Do you want to log in through Google? Do you want to log in through Facebook? Do you want to log in through LinkedIn? Like, what do you want to use to log into this website? And then you decide on your provider, you log in, you redirect with an access token that says, hey, yes, I have successfully logged into this other website, which is allowing me to share its access with the website I actually want to log into. And typically that will validate the token. It will typically do a bunch of other things, like maybe it will like look at what you can access, resources you can access on Facebook. Maybe like tries to copy across like everything you like from Facebook to its system. It will then create your user if it doesn't exist typically and link up the provider. Sometimes some websites allow you to have multiple logins, so you can log in through Google or Facebook, even like at the same time, like those accounts are linked, in which case you kind of have this concept of like linking a provider. And then typically we convert the access token to a local system one, so we don't have to keep refreshing it through like Google or Facebook. It just makes, like, otherwise the problem obviously is that if you have all these providers, like they have different functions to interact with them. Like maybe Google has like a certain API that you have to call, then Facebook has a different API, and like the names are different, the URLs are different, the bodies of text are different, like, you know, the grants are different, whatever. And so you kind of have all this complexity, and you're like, I don't want to do a deal with that anymore. So typically, once we validate it, we just like convert it to a local one. We go, this is our one. This is all we're going to use. Again, we don't actually have to do this in this case. And it talks about that below here. It says, you can presume you don't have to do this. You can just like store the token as is. But we kind of like semi-convert our own one by like kind of wrapping it with the concept of like what the original provider was. And so, for example, a flow here, we visit a page, we are authenticated, so we log in through Google. Hugo and Instaham. I'm very proud of those names. Anyway, the login was successful, so we redirect. We don't exist, so it registers for us, and then redirects back to the login or back to the homepage. And so the point is you basically just answering a couple of questions. It's actually a pretty sweet lab in terms of like it's actually quite easy. You get given all the tests and a ton of the code to begin with, so hopefully you won't have to spend a ton of time of it because you've got lab 4 as well. But this is due week 7, so you've got plenty of time to do it. So really think about design if you can. And there's a few things to do. And then the last one, which is actually reasonably difficult but not too bad, is the concept of locking. Which is like, hey, you want to lock your user after they try to log in 3 times unsuccessfully, one of the two. Unsuccessfully, blah. Anyway, that's basically it. Let us end this here.